questions and finding out. And we said we are great at that in prep. And then we've gone off in our tree groups today and we have taken part in lots of investigations, lots of experiments, found out some wonderful things. And then a culmination of all that, we have got some wonderful senior boys who are going to show us even more things that we can get excited about. So thank you so much for doing this. We're really excited, especially me. This is my first one. And I'm going to thank you. Thank you very much.
Hello everyone, and welcome to our super scientific, slightly silly and curious science assembly. I'm Charles. And I'm Shivan. We are big boys from year 8. And together we are... Actually, we don't have a cool team name. How about the Monsters of Mystery? The Champions of Curiosity? Yes, that one. Today, we want to inspire you and get you thinking about science, cool experiments, exciting demonstrations, and even fire. The theme of today's assembly is curiosity. What's your question? But before we get on with all that, we need to set some rules. Rule number 1. Please remain seated at all times. Even Shivan struggles with this one. Please remain seated unless told to stand up. And there's rule number 2. Rule number 2. Please remain quiet at all times. Please remain quiet, or else the experiments might not work. Dr. Cialbi would be really grumpy. Trust me, it's hard. Trust me, nobody wants grumpy Dr. Cialbi. Shall we try to have a go at staying quiet? Who loves science? Perfect. Brilliant. And rule number 3. Just have fun. Science, just have fun. This is for all of your enjoyment, and we hope you enjoy every second of it. Shivan, slight problem. We can't possibly do all the experiments by ourselves. We need some volunteers. I wonder where we could get them from. Okay, hands down. If you want to be picked, just sit still, remain quiet, and we might just pick you. If you do get picked, you'll receive a pair of super important, super cool, super stylish, super amazing science goggles. Shivan, I'm curious to know a bit more about this year's science theme. Absolutely. The theme is curiosity. What's your question? Science is basically the world's biggest why machine. Someone back in the teacher's day, when dinosaurs roamed the earth, they may have thought, how could you do this? Or, what if we could make our own sunlight? Science isn't just about answers. It's about the questions that get us there. Now, enough talking. Let's do some science. Charles, I bet I could do a better experiment than you. No way. I could beat you any day, rookie. If you are so sure, then watch this. Don't see Alfie. Come here. Good boy. Charles, what do you think if I put this skewer through this balloon? It'll pop, obviously. So we are scientists, so let's find out. Science isn't boring.
Science is an adventure.
Let the adventure begin!
Hi everyone, I'm Josh.
And I'm Charlie, king of fireworks. Today, we've got a big question for you.
What happens when metal salts burn?
So, what happens when fireworks get their colours?
So basically, metal salts are these little things made of salt, obviously, and metal. And when they glow, they become different colours.
So Josh, should we show you how this works?
Yes.
For our first one, we'll use sodium chloride. Whoa! Look at that bright yellow.
That yellow is caused from the salt inside of the sodium chloride. Now, let's try copper salt.
Whoa! Look at that ocean-coloured sparkles.
Now, let's try the final one.
Lithium chloride. Whoa! Look at that crimson red, everybody. So, metal salts plus heat equals colour.
This is just like science colouring.
Yeah, except artists use it in the night sky. They use it as a canvas instead of a paintbrush.
Well, I mean, I think this is science magic.
It's not magic.
Science magic.
Who's ready for experiment number 2? For this one, we'll be using rainbow-coloured beakers. It's interesting how different each metal salt has a different element inside of it, and that's why it glows a different colour. So, as you can see, quite fascinating how the different elements inside the salt affect the colour of the flame. So, leading on to our final experiment, the grand finale. Now, Dr. Siavi is a trained professional, so he'll be assisting us with this one.
We've mixed metal salts into a safe solution and put it inside of a beaker.
And we're going to spray them through the flame, like so.
Oh, hang on. Goggles. Yep. Thank you.
Second one.
Oh.
This is exactly how fireworks work. Tiny metal salts glow different colours as they fly through the air.
And we only discovered that because someone was curious.
So, next time you see a firework, I don't want you just to say, wow.
I want you to say, I wonder how that works. That's how scientists think.
Thank you everyone, you've been brilliant today. Happy Science Week.
Hello everyone, my name is Fletcher.
And I'm Josh. And for our next demonstration, we'll be exploring forces. Fletcher, what would happen if there are no forces?
No forces? Well, we'd all float away like balloons, Our shoes would never stay on. We couldn't sit on chairs. We just slide off. And if I tried to eat my lunch, my sandwich would float into space.
No, not the sandwich.
So today we are learning about something very important. It helps us move. It helps us jump. It even helps us dance.
Oh, I love dancing. Is it music?
Not quite. It's called forces.
Wow, Fletcher, what are forces?
Let me explain. Everyone, put your hands together and rub. What you will start to feel is heat, and that heat is due to a force called friction.
A force can also be a push or a pull.
Now, who knows that special force that keeps us on the ground? Shout it out.
Well done. Now let's test it.
Everybody stand up. On three, I would like everyone to jump. 1, 2, 3, jump! Have a seat.
Did you float away?
That's because of gravity. Now we're going to play a game to feel another force. It's called the friction map. Here's what we do. First, you run and jump onto the map. Try and slide as far as you can, and then put a code where you stop. I'll go first, then Josh. Take your blazer off, Josh. 3, 2, 1.
Oh, well done. Well, you're going to have to hit the wall to beat him. Oh, well done.
Wow, that was harder than I thought. But now for the best part, we need some Year 2 volunteers.
Who thinks
Year twos, yeah? Only year twos? Right, if you want to come down. Come down.
Who thinks the year 2s can beat everybody else?
Yeah.
Watch carefully and cheer them on.
That was amazing.
Now, let's not forget what we learned today.
Forces can be pushes or pulls,
Gravity keeps us on the ground.
and friction slows us down.
Thank you, everyone. Give yourself a big round of applause.
Hi everyone, are you enjoying our assembly so far? Excellent. Well, good news. It's about to get quite popular.
Because for our next experiment,
We are making bubbles! Okay, scientists, big question. What actually is a bubble? Is it soapy air? Is it magic?
a bubble is actually a tiny pocket of air trapped inside a super thin layer of soapy water. That thin layer is called a film, and it's very stretchy.
Like stretchy pajama bottom stretchy? Well, kind of. Water molecules that stick together really tightly.
That's called surface tension.
Everyone say it with us. Surface tension.
Excellent. Surface tension is what makes water form droplets, and it's what pulls bubbles into a round shape, because a circle is the best shape for holding everything together. Circles are basically the superheroes of shapes.
But here's the problem. Plain water is actually quite fussy. It pulls itself together too tightly.
So if we try to make a bubble with just water,
It would pop straight away. That's why we add soap. Soap helps the water stretch. It helps make the bubble strong enough to float through the air, instead of going
Pop! Right, scientists, time for a challenge.
We're going to try and make bubbles bounce.
Wait, bubbles don't bounce.
Exactly. What happens if I touch it?
Pop.
Pop. Every time.
Here's our curious question. How can we stop it popping?
Maybe we need something softer than our skin. And something without natural oils.
What about gloves?
Ooh. Dr. Sialbu will pick 10 brave volunteers.
Right, so your aim is that we're going to blow the bubbles. Okay, we're going to come round, and we're going to flick it off, and you're just going to bounce them with your hands. Okay, nice and gently, nice and flat. Make your hands nice and flat like this, everybody. Okay, nice and flat hands. There we go. Okay, so boys, we're going to go around and blow bubbles. There you go.
Whoa.
Yes. Look at that.
There you go, there you go, there you go.
Oh, perfect.
Keep bouncing. Good job. Well done, everybody. Look at that. There you go. Well done, you guys. That's brilliant. There you go. Okay, one more go. Okay, everybody, well done. I'm going to take the gloves off and bring them to me, please, the gloves, and then you can have a round of applause for everyone, please.
So it's not popping, because the soft gloves don't break the bubble's surface tension like oily fingers do.
Oily skin pops bubbles.
Soft gloves let them survive.
So what have we learned?
Bubbles are made of
Air and soapy water.
And what helps make them stretchy and strong?
so
And why are bubbles round?
surface tension.
You are officially bubble scientists.
But we can't finish without going bigger.
Who wants to see a giant bubble?
Who wants to stand inside of one? Dr. Sialbu to another great.
Stand right in the center. Okay? Arms tucked in, nice and straight. There we go. Okay? Try again. Try again. Are we ready?
keeps the wheel upright and keeps it spinning. Eventually, though, it will slow down and gravity will take action.
Oh, I get it now. Angular momentum is spin power that doesn't want to stop.
Exactly. Take a seat. Put your arms out wide like an airplane wing.
I'm a flying pancake. Slow spin.
Now pull your arms inside.
Whoa, turbo cannon!
See? Arms out, slow spin.
Arms in, force spin.
Your arms like speed buttons. Today we learned that angular momentum just means spin power. Helps bike wheels roll,
Spinning tops twirl.
and you spin.
Spin safe, friends.
And keep your spin power strong.
And remember, with
With
great spin power
comes great responsibility.
Bye, spin pupils. Hello, everyone. Are you ready for the most mind-blowing science experiment ever?
I can't hear you. Are you ready?
Yes, that's the sound of the crowd who's about to see something so wild, so foamy, so gigantic, that even an elephant would fall over in shock.
Quick question. Who likes elephants? And who likes toothpaste?
Then buckle up, because it's time for a super-sized elephant toothpaste explosion!
1, 2, 3. Elephant toothpaste isn't for brushing your teeth. Unless you're an elephant, with a smile bigger than a bus. It's a huge foam eruption made when a special liquid breaks down super fast and makes mountains of bubbles taller than a giraffe on tiptoes.
The chemical that causes the foam eruption is called hydrogen peroxide, and it rapidly breaks down.
We need 3 super quiet, super focused, super scientists who can think like geniuses, stand still like statues, and still look awesome while doing it.
Okay, if you just stand behind each tray, don't touch anything, and follow our instructions, okay? So, Mrs. West is going to give you some goggles. All we need you to do, when we count down, there is a piece of tissue there, okay? You're just going to pick it up, you're going to place it into the flask, and then what are you going to do? Run!
No.
No. You're just going to step back, okay? So, pick it up.
You don't need to unwrap
Yeah,
the tissue.
yeah, exactly.
Wait.
3, 2, 1,
Oh,
go,
step
go,
back,
go,
step back.
That's fine. It's okay. There's nothing to worry about. All this is there. Okay, it's fine. Round of applause for the guy. Okay.
Look at them. They're like friend volcanoes. It's a bubble eruption. It's aiming at the wall. Run!
Do you think an elephant could brush its teeth with that?
When that special liquid breaks down super fast, it makes tons of oxygen bubbles. That was great, but there's one thing that could be better.
Let's go bigger!
Right, we haven't done this in here, so this could be messy, but let's see. Okay, here we go. Okay, we're going to have a countdown. 3, 2, 1,
Go!
Yay! We've got one more. Hopefully this one will go even higher. We're just going to protect these mics, and yeah, I'm going to make sure it doesn't hit anything. So. So this is the finale. This is the last experiment. Hopefully this is going to be worth your while. Okay, we're looking at the countdown. 3, 2, 1,
Go!
That's how you get elephant toothpaste. But before we go, one last question.
The biggest question of the week.
What's your question?
Science doesn't start with answers. It starts with I wonder. I wonder what would happen if. I wonder what would change if.
I wonder what happens if we try it.
That's curiosity.
So this week, test ideas and be brave enough to say,
Let's find out. Keep wondering, keep exploring.
Happy Science Week.
See you, scientists.